Hi, welcome back to this tutorial series on Introduction to MATLAB. In the last tutorial, we discussed some of the operations that can be performed on the matrices. This tutorial is continuation of the previous tutorial and we will see some of the other operations that can be performed on the matrices. Let's get started. So first we are going to look at something called element-wise multiplication and division. Then we will see power of matrices, and next one is the concatenation, and we will then next finally see how to access the each and every element using something called array indexing. So to do element-wise multiplication, let's see, I have a matrix A which contains the elements 5, 4, 6 and 7, which is basically of order 2 cross 2. Next we have matrix B which contains the elements 25, 16, 36, 49, which again contains elements 2 cross 2. Next one is the matrix C which contains the elements 125, 64, 216 and 343. Let's suppose I want to obtain the matrix C using the matrix A and B. So we are going to do some operations on the matrix A and B and we will retrieve matrix C. Let's see if we multiply these two matrices A and B, and if I store it in some variable C, which is again going to be a matrix, what I'm going to get. So if I multiply A and B, which is basically the matrix multiplication, if I do it, I will get 269, 276, 402 and 455, 2 cross 2 matrix. If you look at this matrix we obtained by multiplying A and B, and if you look the matrix C which created here are not the same. So that means we cannot do this operation on the two matrices A and B to obtain this matrix C. Let's see another operation which we are calling as basically element-wise multiplication. So to do element-wise multiplication, we have to use this operator over here with dot with the multiplication. If I do these operations on A and B, I will get this C matrix, and this C matrix actually matches with this one. So what exactly I did here is the element-wise multiplication means we will multiply the corresponding element in the both matrices. So if this element is located at this location, then in the B matrix we have to multiply with the same element which is located on the same location. So this is located in the first row, so this is the first row, and this is in the first column. So this is first column and first row. So this element I will multiply with this one. So I will get 5 into 25, 125. Similarly, I will multiply with the 4 and 16, 6 with the 36 and 7 with the 49. You will get this matrix C. So this type of operation is called as element-wise multiplication. Let's see how we can perform this in the MATLAB. So first I'm going to write the matrix A. So to create a matrix, you already know. So I'm going to supply 5, 4, which is my first row, and then I'm going to supply the second row element 6 and 7. If I press an enter key, you will get a matrix A. Similarly, I can create a matrix B, which is basically 25, 16. This is my first row, and then I'm going to create the second row with 36 and 49. So I will get this matrix B. So if I just simply multiply matrix A and B, which we did in the earlier tutorial, so if I press an enter key, you will see you will get this result, which is not the required result. Now to obtain the required result of matrix C, I'm going to do something called element-wise multiplication. So to do the element-wise multiplication, we have to use this special symbol with dot with the multiplication. So I will use this multiplication, and in front of that I will write this dot. So this basically means we are doing the element-wise multiplication. That means the matrix A element will be multiplied with the elements of the matrix B. So this is called the element-wise multiplication. Similarly, let's do the element-wise division. So I can do the same operations by using this operation over here. So you know, for the division we use this backslash symbol, and to do the element-wise division we have to use this dot symbol, which will basically divide each and individual element. If you do this operation by pressing an enter key, so MATLAB will give me this D matrix, which is element-wise division. If you have performed matrix division, which is A by B, it simply means we have to divide matrix A with the matrix B, so you will get this different result. So these two results are different because this one is the element-wise division and this is the matrix division. Next we are going to see how to calculate the power of a matrix. So let's create a matrix F, and let's suppose I want to create a square, which I can do with the help of this a into a. So I am doing basically the matrix multiplication, and in this special case I am multiplying matrix A with the matrix A, which means a square. So if I press an enter key, you will get that the F is 49, 48, 72 and 73. Instead of that, I can do the same operation by using some special operator. This symbol over here with raised to the power, you can access it on the keyboard using shift plus 6. That means we are raising power to the A. Then I'm going to supply the number 1, 2, 3 that represent how many power we want. So let's suppose I want to calculate a square, so I will just simply use this symbol and then I will supply 2, and this will give me the a square. Instead of that, let's suppose I want to do the power of individual element. So let's create a matrix G. Then I'm going to use the same operation, but instead of that, in front of this I'm going to use this dot. So this dot basically means we are doing the element wise operation. So either you do multiplication, either you division, or you do the raise to the power. You have to use this dot if you want to do the element wise operation on the matrix element. So if I do that, you will get this 25, 16, 36 and 49. If you clearly see the matrix B, so let's access the matrix B by pressing B and press an enter key, you will get the matrix B. So matrix B is basically the same as the G matrix. So that means B is actually the A to the power 2 with element wise operation. Okay, so this was how we can do the element wise operations. We saw multiplication, division. So if you just multiply two matrices, you will use this star symbol. For division, you will use this backslash symbol, and to the power you will use this raised to the power symbol. And to do the same operations in the element wise operations, so we have to use dot with the star, then dot with the division symbol, and dot with the power symbol. So these three operations will basically do the element wise operation, and these operations do the matrix multiplication, division and the matrix to the power. Okay, so next we are going to see, let's suppose I have a matrix A and I have a matrix B, and I want to create a matrix, let's suppose H matrix, which contains all the elements that is contained in the A and B. So the one way to do that is we will just start supplying individual elements. So I will supply 5, 4, then I will do 6, 7. Now I'm going to add the element in the B to this matrix. So I will supply 25, 16. Then I will supply 36 and 49. Now press an enter key. Now you will see that if I do this, it's basically creating a matrix. So this is the matrix A and this is the matrix B. Now instead of applying these individual numbers, what we can do is something called concatenation. So to do that, I'm going to supply matrix A, and then I'm going to use this semicolon, and then I'm going to use this matrix B. So if I press an enter key, you will get the same matrix as we created using these elements. So this operation is called the vertical concatenation. So we added matrix A and B in the vertical direction. So this was A matrix, then I joined this another matrix B in the rows. So this is first row, this is second row, now we have third and fourth row. So this is called as vertical concatenation. We can similarly do the operations in the horizontal direction. So to do that, I'm going to supply A, then I'm going to use space or comma to add in the horizontal direction. So if I press an enter key, you will see a matrix H is created, which contains the elements now in the column direction. Okay, if you clearly see over here, so this basically we are doing concatenation of individual elements, and over here we are doing concatenation of two different matrices. So these are basically the same operations. So we are doing concatenation here as well, and over here we are also doing concatenation, and while creating these matrices also we are doing concatenation of individual elements. Next we are going to see how to access the elements that is present in the matrices. So let's create a matrix A. Remember, A is already created. Now I am supplying other values to it, so it's just simply going to replace the value present in the in this variable A. So let's create matrix A with the elements like 1, 2, 3, and let's suppose 4. Then I will use 12, 13, 14, 15. And if you clearly see, I'm basically creating 4 columns because I've supplied 4 elements in the first row, so it will create 4 columns. Then again I have to supply these 4 elements, and let's create one more row with the elements like 7, 5, 8, 9. Press an enter key. I get this matrix A, and you know you can access the size of this matrix A by using this size command. So it basically says it has 3 rows. The first element represent how many rows we have, and the second element represent how many columns we have. So we have 3 rows and 4 columns, right? Now what I'm going to do is I'm going to access the elements that is present in the matrix A, so which is basically done by something called array indexing. So let's first move to the workspace and let's see how to access the elements. So a window with the name variable is open, and if I select this first element which is present in the first row and first column, if you move to the variable tab and you see in the selection bar, so you will see it says rows 1, that means in which row I am right now, and it says in which column I am. So I am basically in the first row and first column. If I move to this one, you will see the number here changes. That means I am still in the first row, so this is basically first row, but now I am in the second column. So this basically is a column, so I have moved to the second column. Let's select this element 14. So if you select this one, you will see I have moved to the second row and in the third column. So if you move in the variable tab and see over here selection, so you will see it's second row and third column. Now if I select this one, you will see this element over here 15 is the last element, and beyond it there is no element, it's empty over here. So our matrix is confined in this region. So this last element, if you see in the variable over selection, you will see that it says columns mean end. So it's fourth column, but it is written as end. That means basically it is last column. And right now I am in the second row over here. If I select this one, so you will see this is the last row and there is no element beyond this, and this is also last column and no element beyond this. So you will see that in the variable tab, in the rows it says and, in the columns it also says and. That means it is a last column. So I can access last row and last column using this and command. Another thing to notice over here is if I select multiple elements, so you can just simply select multiple elements, press shift key and press your arrow on the keyboard left right. So I've selected these 4 elements 7, 5, 8 and 9. Now let's see in the variable tab, in the selection bar it says rows mean end, so it is single row, so which is third row. So I've selected third row and all the element that is present. So that means all the element in the third row means all the column you're selecting. So if you see in this location column, a column is appeared. That means it is accessing all the elements that is present in the third row. That means all the column are accessed. If I just select 2 columns or 3 columns, now in the variable tab the column showing is 1, 2, 3. That means it is selecting first 3 columns, or I can select last 3 elements. So I am starting from 2, so this is basically second column. I am in the third row, that means last row, so that means end. In the column it says 2 to end, so I am starting from the second column and going up to end. This basically means 4. So this is how we can use indexing. And to do in the command window, what I'm going to do is I'm going to write A, then I'm going to use this index bracket, right? So because we are calling this matrix A, and now we will supply number of rows or number of columns. So I will supply, let's suppose I want this 13 over here, right? So this 13 I want. So if you see, this is first row and this one is the second row. I am basically in the second row and this is also in the second column. So to access 13, I will press 2, then I will supply comma, and then I will press 2. So it says first we have to supply row number and then I have to supply column number. So if I press A2, 2, that means second row, second column. If I press an enter key, you will get the element 13. Okay, that means we are present in this second row and second column, so this element 13 gets accessed. Similarly, you can access, let's suppose I want 15, so this is my second row and the last column. So I will supply second row and last one is the fourth column. So I can access this way, and there is another way that we saw in the workspace. variable, that if I want the last column, I can use end command. This end command is helpful when you have large number of columns. Let's suppose you have 100 and 1000 of columns or 100 and 1000 of rows, and you want to access the last row. You can use this AND if you want to access the last row or last column. Now to access the multiple elements, what I'm going to do is, I want the second row element, so I will use this 2, so second row, and then I want how many columns I want. So I will start from first column and then I will go up to 3. So I'm selecting all the elements present in the second row, and I will select 1 to 3rd column. So if I press an enter key, you will see that if I press an A and enter, you will see that A has basically 12, 13 and 14 elements in the first 3 columns. So that's the way I am accessing here. So I will press 2, the rows number, and then I will supply the columns, all the columns in which the elements are located. So it's basically located in these first 3 columns, so I will supply 1, 2, 3. Okay, so similarly, if you want all the rows, let's suppose I want all the elements that is present in the second column, right? So remember, first we fix the row or column. So I want all the element in the second column, so I've specified the column number, so I will specify the column number. Then I want all the elements, so when I'm saying all the elements, then we use colon operator. That means access all the elements, and in which location, in the second column, right? So we can do this 2, 3, 5, 2, 13 and 5. So it will give me all the element that is present in the second column. That means we are accessing all the rows. If I want all the elements of A, so I'm just going to use all the rows and all the columns. So I will use double column, right? So I will use double column. Okay, so also in the rows and also in the columns, if I press an enter key, you will see all the elements get accessed. I think you are familiar with the colon. So if you press shift key, and the semicolon operator has this colon operator as well. So if you press shift key and press the semicolon one, you will get this colon operator, right? So this is how we can perform these element wise multiplications and different operations. We also saw how to use indexing, something called array indexing, to access the elements, and we also looked at the colon operator. So this is all about today's tutorial. In the next tutorial, we will use this colon operator to create a vector, and we will also see how we can use the linspace command to create a vector using these two ways. Using colon and linspace command, we can create a vector between 2 elements. I hope you like this tutorial. Please like, share and subscribe. I will see you in the next tutorial. Thank you very much.